When the FWD raw data files have GPS coordinates associated with them, DAPS enables to visualize part of the information that was collected during the testing by converting said information into Google Earth compatible native file. At the moment, I have 9 different raw data files or 9 different FWD alignments, as we wish to call them, and they all have GPS coordinates associated to their FWD stations. So let's say that I want to visualize the FWD stations of just of the first alignment, of alignment A1. I can purely simply go to the menu File, selected by Test Data Visualization, then Stations Location, and then Single Alignment. When I do that, DAPS automatically creates a Google Earth file with the information that relates to the file to the raw FWD raw data file A1 that is selected right now. And if I go to Google Earth and I open that file, here we are. We have all of the FWD stations that were listed in the A1 file, and they are all here. So if I go back to that and I wish to visualize instead of just the station A1 or any particular raw data file individually, let's say that I want to visualize all of the 9 raw data files that I have loaded, the information of all of the 9 raw data files that I have loaded at the moment. What I have to do is follow the same procedure, go to File, Test Data Visualization, Stations Location, but now I'm going to, instead of single alignment, I'm going to select all alignment. And when I do this, uh, this um, this window pops up. I'm going to have to define the name for the Google Earth file, and I'm going to call it all stations. I'm going to press OK. That gives me the message stating that it's already saved that information to file. And if I go back to Google Earth and I visualize that particular information, I see that I no longer just have the FWD locations of the raw data file A1 that I had selected previously. I now have all of the FWD stations that were performed in this particular case in this airport apron, and that corresponds the entirety of all of these 9 raw data files. So DAPS also allows me to get information and statistical treatment of the deflections by going to the option normalize deflections, and then I have 3 different selections or options. First sensor, which will give me a statistical treatment of the deflections that were collected in all stations with the sensor at the center of the load plate. D1 minus D3 and last sensor. Depending that last sensor depends on the number of sensors that were used in any particular test, but DAPS will automatically select the last one, be it 7, 8, 9. So it will always be the last. So let's say that I want to visualize information for the first sensor. Once again, I'm going to have to find the name of the file. I'm going to call it first sensor. I'm going to press OK. And immediately that provides me with information, statistical information on the normalized deflection that correspond to all of the FWD stations of all of the files that I have loaded currently. And basically what DAPS does is subdivide the station accordingly to their deflection at the center of the load plate by intervals that consist of 12.5%. So you see that the first we have 8 intervals. Each of them corresponds to a particular interval percentage. So the first one will be 0 to 12.5%. The second one will be 12.5 to 25, so on and so on until we reach the last interval, which is 87.5 to 100%. each of the stations that are going to be represented in the KML file will have a distinct color accordingly to the interval which they belong. And cold colors, namely blue, represent represent the FWD stations with lower deflection. So you see that for each interval, we have a minimum and a maximum range of deflections, with the maximum range of one interval being the minimum range of the interval that follows, which is exactly the same philosophy as the percentage interval. So blue represents FWD stations that are deflecting less, and warm colors such as yellow, orange, and red represent stations that are deflecting more. And the green color represents stations that are deflecting, that have average deflection. So let's call it that are somewhere between low and high. So that they'll be medium. So I can save this information to a spreadsheet or to a text processing software, like we've seen before, just by selecting the option copy to clipboard and then pasting it directly in the software of our choice. So I'm just going to close this window. Dapps once again tells me that it created a file. And if I go back to Google Earth and I visualize the file that I just created, you'll see that we have once again exactly the same representation, all of the FWD stations that were performed with within this airport apron, but now they are represented each with one color. So we no longer have just information on their location, on their specific place in which they were made. We also have information. Um, we have also visual information that allows us to immediately tell the locations in the pavement that are deflecting more and the locations that are deflecting less. For example, if I select this particular station here, it's going to tell me that it's station 14 from alignment A9. It will give me the corresponding distance that was stated in its raw data file, and it will tell me that the normalized D1 deflection is of approximately 638 microns. If in the same alignment I select the opposite one of the stations that is in the opposite direction, I'm going to see that I've selected station number 1 of alignment A9 at a distance of 0 meters, and that the normalized D1 deflection is now approximately 196 microns. So it's deflecting much less than this particular station here, and that is immediate to visualize because where we have stations depicted with the red color, we have higher deflection. That goes from orange to yellow, from green to blue. So when there's a transition that was represented with this particular table, if you recall. So this legend here was exactly this, that is transported to the Google Earth file. It's exactly as it was depicted in with the depth in that window of the depth software that is automatically created when you generate the KML file with this information. So each FWD station is represented accordingly to its own deflection. The color with which the stations are represented belongs immediately identifies the interval in the statistical interval of deflection to which it belongs. And there's also another way to make maps out of the information, which is if we go to File, the option File, Test Data Visualization, and then we select the option First Sensor Mapping. Now I'm going to call it First Map. And if we switch to the mapping utility, we go to the menu main, then module, and we switch to mapping utility, and we load that particular set of data, first map that we just created. So now we have taps automatically create a heat map of that of that that airport apron. So if you notice, it is exactly the same shape and format and color distribution as we have in the Google Earth file, but it's just represented as a solid instead of discrete points, and we can add the scale to it. So it's right now we are visualizing the information in percentile in the visualizing information accordingly to the statistical divisions of the deflection. That's why we have 8 colors that represent each of the 12.5% intervals. And that's why also because the scale goes from 0 to 100. If I wish to visualize the information instead of being in terms of percentile, in terms of actual deflection, I can just uncheck the percentile format option here, and it will look like this. I can also update the title of this parameter that we are visualizing, because it's the 1 micron and not stiffness of the subgrade. It's the default, but we can change it. We can also add the coordinate, the latitude and longitude coordinate, but I'm not going to do that because of the question of privacy of the data. And we can, of course, purely simply copy all of this information to clipboard and then save it directly into another software or save it to file.